Hi to everyone, I am Fiorella Zampetti and actually I am a postdoc researcher at the University of Sagno and I'm going to report on our empirical characterization of best practices in continuous integration. As we already know, continuous integration has been defined by Fowler as a software development practice where members of a team integrate their work very frequently to identify integration errors as soon as possible. Previous literature has already determined some benefits of adopting this kind of practice, like improvements in developers' communication or increase in developers' productivity. But at the same time, the CI adoption is still very challenging. Indeed, it is mandatory, a cultural shift, and very often there is a completely lack of fully automated test suite. Duval has already defined a catalog made up of 50 patterns and anti-patterns dealing with the CI, but to the best of our knowledge, there are no previous studies aimed at identify the best practices that developers usually incur while using and maintaining SCI pipeline, and we also tried to quantify how developers perceive these anti-pattern. For this reason, we have conducted 13 semi-structured interviews with practitioners working with CI, and we also mined Stack Overflow discussion dealing with CI topics. In the end, we filled out applying a card sorting strategies. We were able to fill out a catalog made up of 79 CI bad smell grouped into 7 different categories. While some of these smell are pretty in line with what already reported by Duval, such as the need for having branches that are frequently merged and synchronized. So the anti-pattern is related to having edged and unsynchronized branches, and at the same time have another bad practices that is confirming previous literature is related to having a broken master. We also found some smells that are contradicting with what already reported by Duval. For instance, some of them rely on setting up the right infrastructure. Indeed, today this is not a big deal unless you work on embedded software which use expensive and complex hardware, and at the same time, while Duval discourages a told usage of nightly builds, developers still use it for computational and intensive tasks like the execution of security and performance testing. While looking at build script smell, we found some smell related to the abuse of shell script, having complex scripts and, most important, scripts that are highly coupled with the environment. Looking instead at the build outcome, one of these smell is related to poor build observability. For instance, having build errors that are not clearly visible in the build log, as well as sent failures notification only to DevOps that explicitly subscribe. Looking instead to specific categories, tasks executed during the CI pipeline, we found as bad practice the skipping of tests and quality checks in order to have a green build. The main goal is to have a green build highlighting the lack of errors inside the process and not hide the problems itself. Another important smell is relating to failing to configure quality checks. Indeed, what we found is that developers usually rely on the default checks that produce unneeded warnings, but more important, miss some relevant ones. As main outcome of our catalog, we have tried also to derive some implication from different stakeholders. For instance, as regular practitioners, we suggest to not use out-of-the-box tool and try to favor specific portable tools over hacking. As regard researchers, we have the need for developing automated CI bad smell detector, as well as provide support for failure analysis. And finally, as regard educator, we suggest to teach CI culture, not just CI technology.